think it's on. Alright, chapter 4, lesson 1 on scale drawing. So I'll give you a minute to write this down. I'm going to look at remote control cars for a while. Ooh, the Rampage MTV3. The monster truck of all monster trucks. This is $859. Oh my goodness. A good remote control truck, I guess. 1 to 5. Wow. Let me copy this one and then come back to it later. Hope I don't forget. Alright. The scale drawings. Our central question for this week. How can proportional relationships be used in geometry? Right, we've moved on. Past percents into shapes. So Geyer gave me the notes. She handed them to me at the end of the day, which was her mistake because I forgot where I put it down after she handed it to me. So I made this up myself. Hopefully it's pretty close to what she wanted. If not, I'll get yelled at and you might have to redo this. Fingers crossed. Scale drawing, scale models used to represent objects that are too large or too small to be drawn or built at actual size. And then the scale is the actual ratio we use to compare the size of the drawing to the real thing. Okay, this actually gets used all over the place. Like here's our social studies example. We have distance between two cities on a map as 4 centimeters. And the map uses a scale of 1 centimeter equals 24 miles. What's the actual distance between the two cities? Okay, oops, go away. So what we're going to do, we said still proportional relationships. We're still going to write a proportion. So we're saying we're comparing distance on a map to the actual distance. Actual. Okay. And then on one side, we're always going to put our scale. So on the map, 1 centimeter. And then the actual distance for every 1 centimeter is 24 miles. Okay. And on the right side of our proportion, we put what we actually care about. Since it says the distance we care about is 4 centimeters, what is the actual distance? Okay. The left side is always going to be the scale, and the right side is always going to be the reals. This is what we care about. Then once we have our proportion, same as always, just cross multiply and divide. We've got, well, I should write this down because I always write this down. Cross multiply and divide without fail. So we've got 24 times 4, and that is 96. And then 96 divided by 1, and that's because it's a new chapter. We can work this out the long way. 96 divided by 1 is 96. So the actual distance between two cities, or these two cities, is 96 miles. This one was pretty straightforward because I gave you all the numbers. But what you might have to do, if you're in social studies, you've probably seen it, like if you have a map of someplace, draw someplace nice here, and go up, and then there's this part here, and then there you go. So in the bottom right corner, or left corner rather, there'll be like a little bar here, and it'll say 1. This is America, so 1 inch to, I don't know what this scale would be. This looks like 200 miles. So it'll tell you the scale on the map. You just have to look for it. And then if you want to know this number here, you would just pick the 2 points you care about, and you would actually just measure it like a ruler or your fingers, or guess at it, because it's all scale. And then that's how you write your proportion if you need to make your own picture. Okay? Alright. So let's go on. So number 2, our business example. We have an artist creating an advertisement for a cell phone using a scale of 5 inches to 1 inch. The actual phone is 4 inches long. How big will it be in the advertisement? So I don't know if I wrote this down super clear way. So 5 inches is the advertisement. It's like a big ad, right? We gotta blow up cell phone, make it look bigger, more impressive. Especially because in the book it's like a flip phone, which is not selling too well right now. So we can say, call this one our advertisement on top over actual. Okay. And this time we have every 5 inches in the ad is 1 inch of actual phone. And that equals, and now this time it tells us, that's 4 again, that's kind of boring. This time it says the actual, so not the scale, but the original amount, 4 inches, so we put that on the bottom. So again, you're writing proportions. It's all just, can you put numbers where they're supposed to go, which is why we always make a key. We want to know what will that be in the advertisement, so it tells us we're looking for this number up top. Again, we cross multiply. And divide. And scales are pretty nice because more often than not, the scale is something over 1 or 1 over something. So when we cross multiply and divide, the math's not too bad. Like this one is just 5 times 4, which is 20. And then we divide that by 1. And anything divided by 1 is just itself. So in the advertisement, we'll have a 20-inch tall phone. And that's it. Nothing's really changed. It's just a different new vocabulary, scale, right? We're still just writing proportions. We're still just solving proportions. Okay. Alright, and then one more nice and easy is scale factor, which is the same as scale, basically, except we simplify it as much as we can, and then we don't worry about the units. So we want to make sure that we convert everything to the same units, so that way I don't even have to write it down. We want to end up with just one number. So if we say, what's the scale factor of a model sailboat with a scale of 1 inch equals 6 feet? So let's say I want to convert all of this to inches. I have 1 inches equals 6 feet. I want to convert, so I'm going to put it over here. Everything to inches. So we need to remember, and we have a chart for this, or you have the internet for this, that 1 foot equals 12 inches. So if we have 6 feet, it's going to be 6 times 12. Oops. Times 12. Or 12 times 6. Which gives us 72. And then this is in inches. So now we can substitute, instead of saying 1 inch over 6 feet, we can say that's equivalent to 1 inch over, and we said 6 feet was 72 inches. And the reason we do this is because we want to write it without units, And if we have inches divided by inches, we can cancel like units. So all we're left with is a scale factor of 1 to 72. And that's our answer. So all we did is we just converted one of our units to the other, so we can write our scale as just a ratio. We don't have to worry about any units anymore. So then we could say if we have any part of the boat, like say the boat was, and this is the notes part, everything else is just sort of fun. Let's say the actual boat is, let's say 24 feet long. Or how big is the model? And then without even having to worry about units, we can just say that it's just going to be whatever the actual thing is times the scale factor. And we can get our new units by just multiplying the numbers together. This would be 1/3 of a foot. Or that converts to 4 inches. Right? And then we can check that back with the original, our scale factor. Right? If we did a proportion for this instead, if we said model to actual, and if it's 1 inch for every, what was it, 6 feet, equals what over 24 feet? And then we could say, oh, well, 6 times 4 is 24, and 1 times 4 is 4 inches. We can get the same answer. Okay? So I know this seems sort of redundant right now, but later on, because this is really setting you up for the future, spoilers, where scale factor becomes a much bigger deal. But this is just an introduction. You're going to get plenty of practice. Okay? And then, what were we talking about? Oh, like a big thing that scale gets used for the collectors out there. Like the little, like model cars. You get them in all these different scales you can get a car in. Like these tiny ones, like the Hot Wheels you see at Toys R Us. Right? And then you get big ones. These ones you'll see at like, what's that place called? Like Texas Toys with a Z. Right? Real collector's things. And then the one I found, which I don't know if this is gonna work right. Yeah. Oh. Let me just try it. Let's see what comes up. Nope. Okay, hold on. I found this was an $859 model truck that I want to buy because I want to see if it's worth it. Let's see. Bam, look at that thing. And this says it's a 1:5 scale, which means that this is 1/5 the size of an actual truck. So there's no pictures of it out like doing things. It's always just white background. But I want to see how big it actually is. Okay? If you can find me one of these, bring it in. Okay. Alright, that's it. Okay. Good night.